Welcome to the world of calculus. Calculus is a branch of mathematics that deals with continuous change. It is divided into two major branches: integral calculus and differential calculus. Integral calculus is about finding areas under curves and the accumulation of quantities. We use the integral symbol, which looks like a stretched out S, to represent integration. Differential calculus, on the other hand, focuses on studying rates of change and slopes of curves. The derivative symbol, often written as d over dx, signifies differentiation. We will explore both of these branches in more detail. Calculus is fundamentally about understanding and quantifying change. Change is all around us. It is the core principle for the most important engineering feats. For example, consider a moving car. Calculus can help us determine how fast the car is going at any given moment and how quickly its speed is changing, which is acceleration. Similarly, in the world of finance, stock prices are constantly fluctuating. Calculus can be used to analyze how rapidly prices rise or fall, and to identify when they reach their peak or bottom. One of the fundamental concepts in calculus is the derivative. A derivative measures how a function changes as its input changes. In simpler terms, it tells us the rate at which a quantity is changing. Mathematically, the derivative of a function f of x is often written as f prime of x, which equals dy over dx. This notation represents the instantaneous rate of change of y with respect to x. To visualize the concept of a derivative, think about the slope of a curve at a particular point. The slope of the tangent line at any point on a curve is the rate of change at that point. A steeper slope indicates a faster rate of change, while a flatter slope indicates a slower rate of change. In essence, the derivative gives us the slope of the tangent line to a curve at any given point. The diagram shows the curve line and tangent line and also a point. Let's look at a specific example to understand how derivatives are used in practice. Imagine a position function s of t that describes the position of an object at any given time t. Let's say s of t equals 5t squared. This means that at time t, the object's position is 5 times t squared. The derivative of this position function gives us the velocity, which is the speed of the object. In this case, the derivative of s of t, denoted as v of t, is equal to ds over dt, which equals 10t. This means that the velocity of the object at any time t is 10 times t. Building upon the previous example, let's explore the concept of acceleration. We know that the velocity function v of t is equal to 10t. The derivative of the velocity function gives us the acceleration, which is the rate of change of velocity. In this case, the derivative of v of t, denoted as of t, is equal to dv over dt, which equals 10. This means that the acceleration of the object is constant and equal to 10. Derivatives are incredibly useful for optimization problems, where we want to find the maximum or minimum value of a function. For example, a company might want to find the production level that maximizes profit. By setting the derivative of the profit function equal to 0, we can find the critical points where the profit is at a maximum or minimum. Similarly, we can use derivatives to find the most fuel-efficient driving speed, minimizing the cost of fuel consumption. Again, we would set the derivative of the cost function equal to 0 to find the optimal speed. In summary, derivatives are a powerful tool with applications across various fields. In science and engineering, derivatives are used for motion analysis in physics, reaction rates in chemistry, and system optimization in engineering. In business and economics, derivatives are used for profit maximization, cost minimization, and market trend analysis. Derivatives help us understand and optimize the changing world around us, enabling us to make better decisions and solve complex problems. From engineering to business, derivatives enable us to quantitatively and qualitatively understand change. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.